In this section, we'll be studying parametric equations. In our past sections, we look at a single equation that's written in the terms of two variables, x and y, and we use these equations to graph a curve in a plane. Sometimes in some scenarios, it's necessary to introduce a third variable to graph our curve in a plane. Here's an example of us using a third variable where x is written in terms of t and y is also written in terms of t. Now these two equations that are x and y is written in terms of a third variable is known as our parametric equations, and t here is known as our parameter. Now our parameter doesn't have to be t, it could be anything. It could be theta, which stands for our angle. Here this could be t, which stands for our time. So our parametric equations are basically two equations where x is written in terms of, for example, t. So here we're saying x is f of t, and y is written in terms of our third variable t also. So y is equal to g of t. Now, if f of t and g of t are continuous functions over the interval for t, then the ordered pairs f of t and g of t, which is really our x and y value, is known as a plane curve. So the ordered pairs produced by these functions over the interval t is known as a plane curve. Here we have an example of sketching a parametric equation. Our first equation is that x is equal to the square root of t, and the second equation is that y is equal to 1 minus t. Well, we know from our radical here that t cannot be less than or equal to 0, since we're finding the square root of t, and t cannot be a negative number. So our initial thing to do is to choose points for t. So we're going to choose, well, I've gone ahead and chosen 1, 0, 1, 4, and 9. And the reason I chose these points was because it's easy to find the square root of those numbers. Or you could choose anything, especially using your calculator. Now we need to find x. So when t is equal to 0, then x will be equal to 0. Since we're finding the square root of 0. When t is equal to 1, the square root of 1 is 1, so x is equal to 1. When t is equal to 4, x is equal to 2, and when t is equal to 9, square root of 9 is 3, so x is equal to 3. So here we have our x values. To find our y values, we substitute e in our second equation. So this is 1 minus 0, which is 1. Then we have 1 minus 1, which is 0. Then we have 1 minus 4, which is negative 3. And then 1 minus 9, which is negative 8. So now we have our x and y value. To sketch the curve represented by the parametric equation, we're only going to plot the x and y value. So we still go back to 0 and 1. So here we have 0, 1, 1, 0, 2, negative 3, and we have 3 and negative 8. When we connect our points, we get this curve. So this is our plane curve represented by those two parametric equations. Now the direction of our parametric equation is known as the orientation. So the orientation is the direction in which it's going. So here we're proceeding from this point to this point. And we can always tell the orientation because we start with a smaller t value. So here is 0, then we went to 1, 4, and then 9. So our orientation will be in this direction. Here's another example of sketching a parametric equation. This time our parameter is theta. So our first parametric equation is x is equal to 6 sine 2 theta. And our second parametric equation is y is equal to 6 cosine of 2 theta. So here's our table where theta is our parameter. We're going to choose values for theta. I've chosen 0, pi over 4, pi over 2, 3 pi over 4, and pi. So now we need to find the values for x and the values for y. We know x is equal to 6 times the sine of 2 theta. So here we have x is equal to 6 sine 2 times theta. If theta is equal to 0, then this is 2 times 0. So this becomes the sine of 0. We know that the sine of 0 is 0. So 6 times 0 is 0. So here, this is how we got our 0 here. When theta is equal to pi over 4, then it becomes 6 times the sine of 2 times pi over 4, which gives us pi over 2. The sine of pi over 2 is 1, so then this becomes 6 times 1, which is 6. And similarly, we're going to do the same thing for pi over 2, so it becomes 2 times pi over 2, which is just pi. The sine of pi is 0, so 6 times 0 is 0. And we do the same thing for 3 pi over 4 and pi. We're also going to do the same thing to find y. Y is equal to the cosine of 2 times theta. So 2 times 0 is 0. The cosine of 0 is 1. So it's 6 times 1, which is 6. We're going to do pi over 4. 2 times pi over 4 is pi over 2. The cosine of pi over 2 is 0. So 6 times 0 is 0. And we continue till we get our table. Now we need to plot our points. Our first point is 0, 6. So we have 0, 6. Then we have 6, 0. Then 0 and negative 6. Then negative 6 and 0. And then 0 back to 6. Now we can see that when we were plotting our points, we went from here to here to here. So the orientation of our graph, of our plane curve, is in this direction, in a clockwise direction.